know it's like, whoa.
Hello guys, welcome back to our YouTube channel Algorithm Pod. My name is Jitesh. So today I am with a new topic of cryptography and network security. So let's jump right into it. Now in this video, we are going to discuss one of the public key encryption algorithm, the RSA algorithm. The RSA stands for Rivest, Shamir, Edelman. Now these three are the names of the scientists which are responsible for developing this RSA algorithm. Now what is the basic idea behind the RSA algorithm? Let's try to understand that. So, it is in mathematics, it is a fact. It is based on a mathematical fact that it is difficult to factorize a large integer. To be precise, large prime number basically. To be more precise, prime number. They use they use private key for encryption and public key for decryption in this algorithm. Now let's take an example and try to understand how this algorithm works. So the first step in this algorithm is that I have taken two prime numbers p and q. You can take anything. For this example, I have taken prime numbers as p as 3 and q as 11 for my answers. Now we need to calculate n. Now we need to calculate n in this step. So what we are trying to do with this thing is we are trying to generate keys, for that is public key and private key. This n and the next is phi n will be used to generate public and private keys. So we are calculating n and we have the formula as p into q, so which will be as 33. And phi n. Phi n basically in mathematics is a Euler-Stoughton function which represents the count of prime numbers, something like that, between 1 and n. Number of primes, it's something like that, it represents phi n. So if we calculate phi n, this is the formula for calculating phi n, which will be, if we simplify it further, it will be 20. Now we need to take the value of e. Now I will tell you what this e is used for in the later steps. Now we need to select a random number e such that the GCD of phi n, meaning this one, and e should be equal to 1, and it should be between 1 and phi n. It means I need to choose a number, any random number from 1 and 20, such that the GCD of that number and phi n, which means 20, should be equal to 1. Now there can be many number, and also e should be a prime. So these are the combination, these are the possible type of numbers which I can choose as my e value for, in order to be conditioned to be true. For this I have chosen e value as 7. You can choose anything, you can choose either 3, 11, 13, the choice is yours. Now in the next step we need to calculate the value of d. Now here we have a condition for calculating the value of d. Now this is the condition. So now we have the value of e as 7, phi n as 20. Now all we need is d, such that the net result of this entire operation is equal to 1. Now, and this should be between 1 to phi n, which means I need to choose a number from 1 and 20 such that this operation should be resulting as 1. So I have chosen my d value as 3. Look at this. 7 3s are 21, 21 mod 20. Mod represents the remainder division, which will be equal to 1. Condition is satisfied. You can choose anything, but the net result should be 1. Now, as I said earlier, the E is used for generating the private key and D is used for generating the public key. Now, private key is represented in this way, E comma N, with a combination of E comma N, and the public key is represented with D comma N. Now, this is how encryption and decryption is performed with the help of RSA algorithm. Now, we have M represents our plain text, C represents our ciphertext. This is the formula for obtaining the ciphertext, M power E mod N. So upon simplifying this, we have M as 2, E as 7, and N as 33 as mentioned in the earlier step. So if we simplify this further, we will get our ciphertext as 29. Now I have taken some small numbers, but when in real time it is implemented, the numbers are way too larger. Now in the same way, this is the formula for decryption. C power D mod n. We have ciphertext as 29, D as 3, and N as 33. If we simplify it, we will obtain our initial plain text. So when will you say that we have performed these steps correct? You should get the initial plain text after performing the decryption as well. Here, which means the in simple terms, LHS equal to RHS. If it is true, if you get LHS equal to RHS, then you can say that we have performed the steps correctly. So that's it for this video. Make sure to like this video, subscribe to our YouTube channel Algorithm Pod. Make sure to hit the bell icon. See you guys in the next